In your future, when you're coding and stuff, one of the things that is a negative of Tidyverse is that it is a package that has been made. Whereas with base R, it doesn't have any kind of dependencies. So with Tidyverse, you've got like dplyr and all things like that. Whereas base R, it's always going to exist. So if you did run your script in 10 years' time, it's got more chance of running smoothly than if you had dependencies on a different package like dplyr. And then finally, there's some practice exercises. So to get the most out of the bootcamp, you've just really got to work through it in a kind of not a slow manner, but just try and take in as much as you can. Manage your own expectations. You're not going to remember everything immediately. That's not going to happen. And learning R is a steep learning curve. So you kind of don't want to put your expectations too high, then get yourself frustrated when you're running a line of code. The passive aggressive butler is just shooting negativities at you. You just want to take it in, manage your own expectations, and it is a steep learning curve, so just bear that in mind. And then the other key point is your first script, which we did mention earlier on, but basically always make sure that you have this kind of first header filled in. And the reason you want to do that is, like I said earlier, you want to be able to understand what you did 5 years ago and know exactly why you did it. The other thing that's also important is your contents page. Now, when you put these 4 hashes at the end, it enables it to be clickable. So you'll have like a bit of a contents page up here, and you can just click through all your different code sections. And then this is like super important, but type it out yourself. So if I just click on one of the bootcamp things here, and if we go up to this piece of code here, what you want to do is you just want to type it out. You don't want to fall in the trap of copy and pasting, just because the more you type out, the more it'll kind of be engraved in your brain. Again, you've got the assign function. You'll get used to using that. Using the concatenate function, you'll get used to using that. And those 2 main things that often at first are really hard, that people kind of just can't get their head around. You know, they'll be putting this in, but they won't put the C in, and they'll be like, oh my God, why isn't it running? There'll be tears and everything. But actually, it's just something really simple as putting the C in. You know, it'll come over time. And then here, understanding what mean is, we will go into a little bit more detail there, but mean is basically our kind of function, and then x is our argument. So we're assigning x to my_length, and then my_length is the vector, which contains 3 numerical measures. But we'll go into that a little bit more, just understanding syntax. So this is probably like the easiest start, but then in another kind of way of thinking, it's not the easiest start because there's no context applied to it. You've just got to sit back, observe it, do it, and then later on, as you go further into this kind of learning our journey, you'll be able to put some more context to things, and then things will start to be easier to understand and just become natural. So overall, each bootcamp page has a little bit of an introduction to what we're trying to kind of teach you within that little page. Then at the bottom, you've got your exercises. Now within the bootcamp, there is solutions to the exercises. So you can check back, but I would advise kind of not really looking at them, because there's so many different ways to do it, and you could do it a very different way to the solution within the exercise, but that doesn't mean your way was wrong. It just means that there's multiple different ways to do these different things. And I think that is kind of everything with regards to an overview. Can I just ask, is anybody actually working on this part of the bootcamp yet? Amy, you mentioned that you're just kind of starting in R. Is this something that you've kind of been working towards, completing the bootcamp and doing any of the questions? Oh, so you finished it. That's good. That's good. And Myoa, I assume you finished the boot camp when you applied for your master's course.
Yes, I have.
Good, good, good. And then I noticed we've got a new person within Harrog, but I might need help pronouncing the name. Sebnam, have you got any kind of R experience?
No, I don't.
Okay, so is doing the boot camp something that you're kind of interested in?
Well, for now, I just need to learn the basic skills and like how I can implement it in my research.
Yeah, no, that sounds good. So the boot camp is really good in kind of helping you do that. So I'll put the link in. I should have done this earlier, but just to show you how to navigate, these are the contents pages. So you can do like data objects, data frames, which is probably more what you'd kind of be interested in for your research. So I'll just pop it in there. So then I'm just going to show you the script that I have. So you can see here we've got our header, our what and our last edited. And something that I kind of have on my desktop is I have like a starter script. I just put it in my desktop just because it's just so easy. Then I just copy it, put it in. And I also have this little bit of code here where I install any packages that I want in just a nice kind of easy format. I also have a little code book, which is in R, which I've started developing recently, so there's not that much in it. I had it all written down, it wasn't practical. So I'm kind of developing a bit of a code book with everything that I need. And then I've also got like a coding management thing, which might help you guys out if you're starting out with the bootcamp. So you could actually put in the links to anything that you see is really useful. So one of the links that I'd probably add on here is some of the bootcamp links, then the R script that it kind of relates to, and what it is teaching me, so the purpose of that. So for example, I've got something like visualizing multiple plots using the matrix function. So it's something really simple, but if you've not done it in a while, you're thinking, how did I do that? So just some really helpful kind of things. But if we go back to this code, we want to put our name in first. So if I put my name in, and the last edited in the global ISO format. Then here you can see I've got the contents page, and you can see here where I've got two example script help pseudo, which is the exact same up here, but here it's got the 4 hashes on. So if you actually click on this line section here, I can actually click through every single element of my code. Now, something that you guys might be confused of a little bit here is this is literally just, we're just looking at the syntax. So I've not loaded any data into R, not done any of that. We literally are just looking at the real kind of basic syntax stuff. So the first thing that we want to do is find how we can get help within R. So before we kind of go to Google or anything like that, we can actually utilize the help function within R. Now we do that by using the function, the argument help, and then we literally type in the function that we're interested in. So if I can run that, or if I just go and change it and I just put help ggplot, which is a package to do kind of graphing, I can also just click F1. And it's looking for it, and it's saying it's not loaded any package, but it can be found in the following. So the actual package that I wanted to search for is ggplot2, not just ggplot. So if I click on that again and then just click F1, still not liking it. But you can click on it, click on the links, and it will take you to the web page as well. Probably not a good example though, that one. So just looking at this kind of page, the actual help page, we've got the name up here, the package that it's within. So this is within stats, compared to when we had the mean one. It had the help, sorry, is in utils, but if we just go on the mean one, you can see that that was in base. Then you've got the name of the actual function, so it's looking for the mean. Then you've got the description, what you're actually doing. Then you've got the usage, so how would you use it? So you use your function, and then you put in your argument x. Now x here is basically what we want to find the mean of. So I think if we did it as x, as let's say a vector, so if I had x and I wanted to assign this to a few numbers, 100, 150, 60, and 70, and I'm going to run that, then what we will see is that it's ran. I've not had any error messages up. If I removed, I've got this weird cursor thing now. Ed, what's the special key function to remove this without having to close it down again?
Which one are you trying to remove?
So can you see how my cursor's changed to a line?
Insert,
Yeah, it's insert. Yeah,
Insert.
exactly. You just accidentally hit the insert key. There you go.
That gets me
Good one,
every
Amy,
time.
too.
I need to add that to my code book because I literally forget that all the time.
Forget it, yeah.
So if I now remove this C here and try to run it again, it's telling me that I've got an error. So this error is what we kind of referred to as the passive aggressive butler. So it's told us doesn't like it, not happy. So it does need the C there because the C tells it that we want to bind that into one thing. Then with regards to actually finding this X, we know we've made it, it's ran perfectly, but where can we actually find it? Where is it stored? And actually, if we go into this environment tab up here, we can actually see our X is there under values. It's numeric, it's got 1 to 4 vectors, and those are the 4 vectors that we have. So now, using my arithmetic mean help function, I know that I can do mean, because that is the name of the argument. Sorry, the function. And then I can put in the X, which is my argument. And there we go. I've got a mean of 92.5. So it's given me the mean. Then there's also this default S3 method. Now, when we talk about S3, we're talking about the data type, but you guys don't need to worry about that at this moment in time. But just something interesting here is this na.rm equals false. So here, the na.rm, which I will use the help function on, just to find out a little bit more about it. But basically what it does is, oh, it's not liking it. See if it runs.
You just scroll down to get the meaning of arguments and the help page for the function. There you go.
Here we go. Here we go. So you can see that it says a logical, which means that it's like logical Boolean. So is it or isn't it? Yes or no, true or false. And what we're saying is, do we want NA values to be included within the mean calculation, or do we not? So here, with it being NA equals false, it means do not strip the NA values before doing the computation of the mean. There's also these other things. So you've got trim, which gives you some information there. And then ... which means further arguments. So there might be more arguments depending on different kind of statistical functions, but just for this mean function, these are the main ones: na.rm, trim, and x. It also provides some more detail regarding the value. So some things that will work or some things that won't work, depending on whether it's a vector or a character, things like that. And then you've got some references. So for example, if you were doing a paper and you wanted to, and this is the beauty of these kind of things, if you're writing your paper, it might be at undergrad level, it might be at master's level, and you just want to do something as simple as the mean, but you can't find the original reference to, you know, where that came about. There's a really good reference there, 1988, right back to the horse's mouth type thing. And they have that for all of them, like even AIC and things like that. So it's great. It also has some suggested ones, but me personally, I kind of benefit the most from these examples. So you can see here, they basically did what we did. So they created a vector, named it X, then they calculated the mean of the X and put it into an object called XM. And then they did something else. So they basically concatenated the two, but also wanted to trim the value X, so the argument X. So all in all there, just from reading that mean paper, that mean kind of help page thoroughly, we've been able to see na.rm, which a lot of students don't really understand that function yet, or even not really fully understanding why they kind of aren't finding a good solution to their problem. It'll be something really simple that they need to remove the NAs or account for the NAs in a different way. And also the trim kind of argument. So next thing is kind of looking at math operators. Now, I won't insult anyone's intelligence, so I'll quickly run through 2 + 5 and 10 - 15. So we're literally just running them and they're coming down the console exactly as you would do in your calculator. And then here we've got some raised to the power of x, where we use this kind of hat function there. So 2 to the power 3 and 9, well, square root of 9, so 3. There we go, nice and easy. Then we can look at the order of operations. Fairly straightforward again, obviously BODMAS. So ideally we'd want 4 + 2, 6, times by 3 to be 12. 18, sorry, that's embarrassing. And then we can also add these kind of parentheses here, which gives us exactly the same, or these ones here, which gives us a completely different, you know, the actual answer of 18. Kind of goes back to BODMAS. Then here there is some different ways of formatting it. Now, ideally, you wouldn't usually format it like this, but I believe that all of the calculations do still kind of work exactly the same. But obviously it's not good practice to have your code without any spaces, to have your code really far apart with large gaps, and you don't need to be kind of odd with how many spaces each time. As long as your code base is kind of the same throughout, then that's good. There is also something up here, whereas if you do have lots of code where you've kind of got one consequence leads to another consequence and then you do the next kind of 5 steps, you can use Control-Shift-A, or you can go on the code and you can actually use reformat code, and that'll give you the ideal format for that piece of code, which is good if you're doing a large kind of function. That's really handy. Then we kind of go on to logical Boolean operators. So 3 greater than 5, obviously we'd expect that to be false because 3 is not bigger than 5. There we go, false. Then here 3 is compared to each of the elements. So we're saying that 3 is less than 1, which we'd expect true. Then we'd expect true again. Then 3 is less than 3, false, because it's equal to, and then false, false, false. So that is technically what we'd expect. So if I run it, yeah, we get false, 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 true, true, true. I've done it backwards. 3 is great. 3 is greater than. Sorry, I read it upside down. So yeah, 3 is greater than, and it'd be false, 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 true, true, true. Then we can use these other kind of functions, which is and the pipe. So an and means and the pipe means or. So if we've got true and true, and I can run that. So it's true for both. And then we've got 3 is greater than 1 and 1 is less than 5, which is also true. And then we've got true and false, false and false. So if we run true and false, false overrides true. And if we run false and false, we get false. They're handy when it comes to kind of getting certain aspects of data. So it might be that you've got all these different values that are even, and therefore you can assign even as true and not even as false, and therefore you can pull all the even values out of the data set or all the odd values out of the data set. Put some data into a variable and then print the variable. So this is what we did earlier with regards to the mean. So we're using the assign function, and then we use the concatenate function. So we've assigned it. Now we've got a new x than what we had initially. We've got 5 values, so 21, 3, 5, 6, and 22. And then if I print that just by running the x, it's given me the list of vectors that were in x. Then now I'm going to ask it, is my x greater than 20? And it's given me a logical for every element of that vector. So is x greater than 20? True. Is x greater than 3? False. Is x greater than 5? False. And if x is greater than 6? False. And then x greater than 22? True. Then we can also use the square brackets to index that specific part of that data vector. So what this has done is it's basically just taken out elements of that vector that where x is greater than 20. So we've got 21 and 22, which were values 1 and 5 of the vector. Now we have got some kind of practice questions. So I don't know if you'd just like me to kind of talk through them, or if you guys want to have a go. I'm easy on. I don't know what would benefit you guys the most.
Maybe talk through these, George, and if we have a little time left over, then we can write our own questions, maybe.
Nice one. So practice question number 1 is name and describe the purpose of the first 2 sections that should be present in every R script. So ideally what we're looking for is the header and the contents. In the header, we want to include our name, we want to include what we're doing, and we also want to include the date in the ISO format. And then we'd also have the contents page, which should be clickable throughout. So we can click in these kind of liney area here and get, clickable contents page of what we've got. Then the next question is, what is the purpose of subset argument in the box plot function? And then there's even a hint here that says use help. So we can actually search for help box plot. And then the argument that we're interested in is subset. So let's just go down to subset. So it is an optional vector specifying the subset of observations to be used for plotting. So it might be that if we have multiple different flowers, but actually we only want to plot some of those flowers that have, let's say, red leaves, red petals, then it will only plot the subset of data with red petals in a box plot. The next one, write an expression using good R spacing syntax that takes the sum of 3, 6, and 12 and divides it by 25. So what we want to be doing here is we're going to use the basic adding up, so 3 plus 6 plus 12. And then we want to divide it by 25, which gives us 9.48. Now, there was two answers that we can get for this. We can do it this way. And we can also do it using brackets. Obviously, the correct way is using the brackets. It's written down there. So we've got an answer of 9.48 and an answer of 0.48. Question number 4. Write pseudocode steps for calculating the volume of a cylinder. Hint, if you do not know it by heart, you may need to research the equation for the volume of a cylinder. For a cylinder of height 3.2 centimeters, radius 5.5, report the volume in centimeters to 2 decimal points of accuracy and use at least 3 decimal points of accuracy for pi. Okay, so I shouldn't cheat, but I need the volume of a cylinder. So let's first start by doing the pseudocode. And by pseudocode, we just mean the steps to be able to calculate the volume of a cylinder. So we might start with saying step 1, find the volume of a cylinder equation. Then step 2, use the equation. So volume for a cylinder equation. Here we go. So volume
That equation, it didn't look right to me. It's not right. The volume of a cylinder is pi r squared. That's the area of a circle times the height. The 2 squared part wasn't quite right on that web page. It's a good example because it tells us yet again that we shouldn't always trust the web.
Yeah.
There you go.
So first thing that we want to do, note here that because I didn't know the volume of the cylinder, my step 2 was kind of a little bit rubbish. But sometimes when you kind of do know more about your problem, it is a lot easier to write pseudocode. But anyway, we've got our equation. We know that pi is 3.14. And we know that the height of the cylinder is 3.2. And we know that our radius is 5.5. So first thing that we need to do is pi times r squared. So it might be that actually we can square root our radius first. So now I can kind of do a little bit more kind of better steps for my pseudocode. So step 2, I can decide to square root my radius. Then I can, step 3, assign the values to an object. And then step 4, implement the objects into the equation. So now I've got a little bit more of a developed pseudo steps, which for finding the volume of the cylinder doesn't seem that important, but the bigger the problem, the more important that is. So I'm going to do r squared. Now, we did this further up here using the hat function. Sorry, the hat syntax. So that one was this one here. So I'm going to do the exact same thing down here, which gives me 5.5. Oh, I can't find it on my keyboard now. Got it. So, and this one is going to be radius squared. And then if I can view that, 30.25. So now I just need to do pi times by radius squared times by height. And it says height has not been found. I don't know if I ran it. So this is written in there. That should be a lowercase p. So I've got a thingy of the cylinder as 303.925. And this one here was 304.11, which I assume is because a different value of pi was potentially used within the calculation.
Yeah, it's probably like Zimik mentioned in the chat that pi, there are a number of built-in constants, and pi is one of them. So it's probably the difference is because there's many more decimal points of accuracy on the built-in pi. That's it.
Mm-hmm. Yeah, so I think you've actually used the built-in pi, haven't you? You've actually done pi.
Yeah, that's right.
Yeah. Okay, so I basically just added one in separately. So again, multiple different ways of doing the same thing.
Sorry, once pi is the inbuilt constant, but it's not protected, so you can replace it with any value. So be careful; you'll have to remove it once you did it.
Fair enough.
Your pi can be 314 now.
Mm-hmm.
Okay.
That is. So this was some other pseudocode. So alternatively, Ed calculated the circle area for the cylinder and then multiplied the circle area by the height. So yeah, just loads of different ways to do the same thing. Ed's was probably a lot simpler compared to mine, but hey ho. Now the final question, I believe, is number 5, execute the code and explain the outcome in the comments. So we've got true, and then 3 is less than 5, and 6 is greater than 2, and is not false by sorry, or false. No, not false. So here, explaining this outcome in the comments is all the components are true, and that's because true, we're telling it it's true, and we're saying that it's less than 3. Sorry, and we're saying that 3 is less than 5, so that in itself exists as one kind of element to this long string of code. And then we're saying 6 is greater than 2, which is true. And then we're also saying exclamation mark false, which in itself is true because we're saying that it's not false, so it has to be true. So yeah, I hope that kind of makes sense to everybody. And I think that is everything. If anyone's got any questions.
Thanks, George. That last little bit of code that you did, could you bring up your screen just again? There's a little trick I use. I use it almost every time I write any script, but it is helpful on pieces of code that are complex and involve several pieces. And like that code on line 171, a little trick that I use, I use it all the time, is you can select subsets of a line of code and run them one by one. For example, you can select just select the first two terms there. Select all the first two terms now. There you go. And run that. And you could run just pieces of code to figure out what each piece is doing. And it often helps, it definitely helps me because I do use it just all the time. And I think of these as little mini experiments, and they're experiments that are fast and free to conduct. And they're really useful. Thanks for doing that, George. Any comments or questions? How can you?
I find with those logic ones, I tend to put in more brackets or parentheses, whatever you call it, just to help my thinking. So I don't know if you could just bring the code up again briefly, George.
You can do that too. You're right.
Yeah, it's just the way I, because it does matter, doesn't it? Well, it doesn't matter, because it's written there, but to help me think, the and isn't 5 and 6, it's a logical expression and another logical expression.
Yeah.
Yeah, I mean, this is one of those things that if particular syntax makes it more readable for you, use it. Yeah, absolutely. This question in the chat, it's a question about how to merge two columns of independent variables to make one. Not exactly sure what you may mean. What do you mean by merging two columns? Do you mean like adding two columns together or something different, Amy?
So I've got two independent variables of selenium and vitamin E, and it's a 3x3 factorial. Some of my data that is not normally distributed, but I've got like a chaperone milk test that's come out with really, really low p-value, so it's not normally distributed. I've tried like going all the way up and all the way down because they're positive, it's like positive, so, and it won't conform to normal distribution, so I need to do non-parametric tests. As far as I've been able to research, there's no non-parametric tests where you can apply two independent variables. So I would need like a non-parametric ANOVA. So I need to basically turn my my 3 different levels of selenium, my 3 different levels of vitamin E into one thing, which is like got the 9 treatments in. So I've then got one independent variable.
Well, there's 2 different parts of this. I'm still not sure I understand the part about merging. Do you want to multiply them or do a math function or just bind them together?
It's effectively just binding them together.
Okay.
Because so they were on, it's like a 3x3 factorial design with 3 levels of vitamin E and 3 levals of selenium.
Okay.
And I've been analysing them in ANOVAs where you can basically say, is vitamin E having a statistical difference? Is selenium having a significant difference? And what is the interaction between the two?
Yeah,
most of it.
We would refer to if you have 2 variables and each one has 3 levels.
Yeah.
We would usually it's confusing the language around this stuff, but the traditional way we would call that a 2-way test. Not a 3x3, just a 2-way test because there are 2 variables. There actually is a non-parametric version of a 2-way ANOVA.
Okay.
And
What is it?
It is implemented in R, and it's called the Friedman test. Spelled a little funny. I can't remember what the name of the function is.
I've tried Kruskal's test and the Mann-Whitney test, but neither of them two will allow to have 2 independent variables.
Nope. Kruskal-Wallis is a 1-way ANOVA, and Mann-Whitney is for the t-test. Hold on a sec.
And stuff. I just couldn't find one that had.
It might just be called Friedman.test, but let me just find
it is.
Yeah,
It's called Friedman duck test.
yeah, yeah. That's probably the one you want. I just wanted to say one other thing about this. That's an interesting question. It's a practical question, and that's that depending on how great the divergence is from normality of the residuals, I guess,
Yes.
depending on how far the divergence is, if it's really far, if it's very skewed and your say your dependent variable, we would never in a million years expect it to be Gaussian for each of the levels combinations.
Yeah.
Then you have to revert to another test. But if it just diverges a little bit, it turns out that ANOVA and other linear models are very robust to small deviations.
Yeah,
This is a
no, I did
subjective thing.
notice that, but my p-value for the Chaparro-Wilks test is 0.000004135.
Yeah.
So
Okay.
it's, I mean, when you
Friedman
plot
test
it on
it
the
is. You
histogram,
convinced me.
it's nowhere close to being normally distributed. So
Try the Friedman test and report back next week. I'd like to
okay.
see and hear it.
So, but if I did want to, because I'm also trying to do like some violin plots to make it look quite nice, is there a way that you can merge them, the two treatments together? I found a bit of code the other day, but it doesn't appear to be working.
Do you mean to make the 9 different levels of
Yeah.
unique combinations? Yeah, I can't. There probably is the short answer, but your experiment's probably small enough. You could just make a new variable
Yes.
and make a new variable with 9 levels if you wanted to do it that way.
Okay. How would I go about sort of? Would I have to assign it then to go through and say, or could I say when this is this, assign 1?
Let me ask you a question about your data.
Yeah.
How many rows are there?
I have 72 animals, so 72 rows.
72 rows. And is is that how many? Do you have a balanced design where there's exactly the same number of observations for each of the 9 by 9?
For 6 of them I do, but for 2 of them, one of the animals died in each group, so I've got like all the same other than 2 groups.
Okay, well, this is a fast and dirty / filthy way of doing it, but if you know where the dead animals are, and you know what rows they belong to, or in other words, what level combinations they belong to.
Yeah.
You could just replicate dummy variables like the letters A, B, C, D, E, F, G, H, I.
Yeah.
And you could replicate each. What is your sample size for each of the level combinations then?
I've got it'll be 7 groups of 8 and then 2 groups of 7.
7 groups of 8 and 2 groups of 7. So if you know where the animals are, you can just use the rep function for replicate.
Okay. Yeah.
And make it automatically. There probably are some automated ways to do it, but with these small data sets, I would probably make sure that I knew the data set and just make the dummy ones. And you could do it in Excel as well. It wouldn't take you very long to do it manually, but you could do it either way.
Okay, thank you very much.
I'd like to see that, show us next week.
Yeah, well, I'm hoping to have it finished by Friday, like all of the statistical analysis for it. So.
Okay, well, thanks again, George. Thanks everybody for coming. We can stop the old recording now. It looked like something weird happened to the recording, like it might have been already stopped earlier. Did stop recording. There we